Hello everyone, hope you all are doing well. So today we are going to do topic 43, that is quality of irrigation water. Quality of irrigation water. Now moving on to this, we need to classify water quality classification. Water quality classification, the first topic of this session. So it is done to get the suitability of irrigation water. It looks for the impurities of water and locates its advantages, and it looks for impurities of water. It looks for impurities of water and locates its advantages and disadvantages, and accordingly water is used, and according to its advantages and disadvantages water is used. It is based on three parameters. First one is total salt concentration. Second one is sodium absorption ratio. Second one is sodium absorption ratio / residual sodium carbonate. Residual sodium carbonate. I hope it is visible. Residual sodium carbonate. And the third one is boron content. So it is dependent on these three parameters, and these three parameters are known as hazards. So now, what are the hazards associated with water quality? So we will, if BPSC asks you this question, you have to describe these three parameters. Hazards associated with water quality. The first hazard is salt concentration, that is salinity hazard. So it affects the growth of most crops. Injurious and dissolved salt are accumulated at root zone. These injurious and dissolved salt are accumulated at root zone, which is very harmful for plant. The second one is solidity or alkali hazard, or sodium hazard, what you want to say. That is alkali hazard. So here it happens when water contains relatively more sodium ions than calcium or magnesium ion. When water contains more sodium ions than calcium and magnesium ions, relatively more, the amount of sodium ion is more and calcium and magnesium ion is less as compared to sodium ion. Here, maintenance of adequate soil permeable for water infiltration. We need to the maintenance of adequate soil permeable for water infiltration. And movement of soil is serious problem, and serious problem. It is very hard to maintain this soil. Breaks down aggregates and affect movement of air and water in soil. It breaks down soil aggregates. So what it does is affect movement of air and water in soil. Affects movement of air and water in soil. Now third one is boron hazard or boron toxicity hazard. Boron toxicity. So we should know that boron is required by all plant in small quantities, but high concentration, when the concentration of boron becomes high, it gives toxic effect to growth of plants. Gives toxic effect to growth of plants. So this was these three. I hope you all understand the hazards associated with all these three. Now moving on, what is the significance of water quality, irrigation water, or significance of irrigation water quality and rainwater harvesting for crop production? This was asked in UPSC in previous years, so you must know this. Significance of irrigation water quality and rainwater harvesting for crop production. What is the significance? First one is it affects yield and quality of crop. Affects yield and quality of crops. Proper management will give us high yields. Secondly, maintenance of soil productivity helps to maintain soil productivity. Soil productivity is maintained. Thirdly, protection of environment. This bad irrigation water is not harmful for our crops only, but for vegetation, for soil microorganism, everything. So by managing this, we will protect our environment. Excess water can be stored for future irrigations. What you do in rainwater harvesting can be stored for future irrigations. Reduce runoff and soil erosion. It will reduce runoff and soil erosion. Rainwater harvesting. Supply of water in dry spells. When there will be dry spells, we will have enough supply of water as we have harvested it. Decrease waterborne diseases. Waterborne diseases. Eighth is better utilization can lead to sustainable development. Better utilization of soil and water will lead to sustainable development with high production and high nutritional quality of crops. Nutritional quality of crops. Last point, that is ninth. Reduce salinity, sodidity and toxic hazard which affect plant growth. Reduce salinity, sodicity and toxic hazard which affects plant growth, which lowers plant growth. So this is the significance of irrigation water quality. Now moving on, what is this was the next topic of this session. This was also asked in UPSC previous years. That is residual sodium carbonate in irrigation water. That is, we have done it just earlier. Salinity, alkali. What hazard we have done it? That is, say, sodicity hazard or alkali hazard. Sometimes I also do get confused. I am also a human being. Residual sodium carbonate in irrigation water. we have need to do in previous years there were short notes was asked on this. So how will we approach this question? So this is residual sodium carbonate is used to indicate which hazard? Alkalinity or sodicity hazard. To indicate alkalinity hazard for soil. It offers RSC index, residual sodium carbonate index. It is used to find suitability of water. This RSC index is used to find suitability of water. Here you can also explain some points of alkalinity hazard. For irrigation in soils, with high cation exchange capacity, CEC cation, cation exchange capacity. When dissolved sodium in comparison with dissolved magnesium is high in water, when dissolved sodium is high in water as compared to magnesium and calcium, dissolved magnesium and calcium, the soils with high CEC, example clay soil is high in cation exchange capacity. Soils are undergoes dispersion. These soils, what happens? Soils, when this is there, when sodium is very much higher than magnesium, calcium, the soils with high cation exchange capacity or clay soils or undergoes dispersion. These soils and undergoes dispersion, which reduces its infiltration capacity, which in turn reduces its infiltration capacity. Clay soils with high RSC indicates water leads to fallow alkali soils. So with high RSC we need to prevent this soil to become with high RSC because it is not good for crops. Now we should know what RSC index is. When RSC index is less than 1.25, the water is safe. When RSC index is between 1.25 to 2.5, it is marginally suitable. Although we need some treatments here, but it is marginally suitable. But when the RSC index, residual sodium carbonate index, is more than 2.5, it is not suitable or unsuitable. So we cannot grow crops in the soils with RSC index more than 2.5. Now moving on, how will you manage this poor quality water? So here we will see management of poor quality water. Management of poor quality water. First one is gypsum application. We can do gypsum application because it will improve our calcium and magnesium, calcium ratio, calcium nitrogen ratio, or SAR, that is calcium nitrogen ratio is also known as SAR. Application applied if soil is alkaline. It is applied when soil is alkaline. When soil is alkaline, we need to apply gypsum. Second, we can do what is grow tolerant crops. And avoid sensitive crops such as salinity. If the salinity tolerant crops are barley, sugar beet, these are tolerant crops. Barley, sugar beet, rapeseed, cotton. So we need to grow these crops, and we need to avoid sensitive crops. And the sensitive crops to salinity is citrus, gram, lentil, pea, etc. We need to avoid these crops and get dependent more on these crops. And for solidity hazard, the tolerant crops are rice, sugar beet, paragrass, sugar cane, cotton, millet. These are sodicity tolerant crops. Well, we need to avoid some sensitive crops. Which for sodicity is groundnut, cowpea, lentil. We need to avoid these crops. And third, we need to improve our methods of sowing. Third, what we can do? Improve our methods of sowing. Third, methods of sowing. What we can do? Ridges and furrows method is used because we need to use ridges and furrow method because in furrows salt accumulates, making it suitable to grow on ridges. Because in furrows what happens? The salt accumulates in furrows and makes ridges suitable for growth, as all the salt is accumulated in furrow, suitable for growth. And secondly, transplanting leads to better crop establishment in finger millet. We need to do transplanting, which leads to better establishment. For example, establishment. For example, we can see this in finger millet. We need to use closure spacing. We need to do optimum and balanced fertilizer used instead of high fertilizer used. Balanced fertilizer used. We need to use drip irrigation instead of sprinkler. Drip irrigation instead of sprinkler, as in sprinkler there is problem of salt accumulation. Provide frequent irrigation. And educate drainage should be there. Educate drainage. We need to have some soil management, good soil management practice to improve soil structure and filtration. We need to improve soil structure and infiltration. We can add organic matter. We can do mulching. So these are some of the things through which we can improve our water quality or fight with our bad water quality. So that's all for today's session. For any queries, do comment. If you like it, please press the like button. Do share and subscribe. That's all for today. Have a nice day. Thank you.